Assembly 7B states, ask questions and answer them based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. The graphical displays our students explore in 5th grade include bar graphs and line plots, also known as dot plots. One way in which students analyze a set of data is to make noticings about the distribution of the data or how it spreads across a graph. In 5th grade, students should describe the center of the distribution by the equal share, the mean. This should be explored visually and conceptually. While students may derive the mean formula, it is not an expectation in 5th grade. One interpretation to find mean is through leveling off or finding the fair share. Let's take a look at leveling off in the following problem. Ms. Smith gives Alex, Bailey, Cole, and Damien candy as a treat. Alex takes 3 pieces, Bailey takes 6 pieces, Cole takes 3 pieces, and Damien takes 4 pieces. Ms. Smith tells them to redistribute the candy so each person gets the same amount. If they redistribute the candy so each person gets the same amount, how many pieces will each person get? We can represent the data in this problem using a bar graph. The question asks us to redistribute the candy or our data so that each person gets the same amount. One way we could do this is by leveling off the data. I notice when I look at the data that each person has at least 3 pieces of candy. So I can level the data off at those 3 pieces and take any pieces away that people got above those 3. Okay, as of right now, everyone has 3 pieces of candy, and then I can share out the part that I leveled off. So Alex would get 1, Bailey would get 1, Cole would get 1, and Damien would get 1. If I level off the data, I can see that each person is going to get the same amount. They will each get 4 pieces of candy. 4 pieces of candy would be what we would have if we redistribute the candy evenly. And we can call that our number, our mean. So the mean pieces of candy would be 4. Students may also choose to level off the data in a different way. Instead of leveling the data at 3 pieces, because each person has at least 3 pieces, and then redistributing all the pieces greater than 3, students may be able to visually see if I take 2 from Bailey and I give one of those to Alex and I give one of those to Cole, I can redistribute the data this way, and now everyone gets the same amount. Everyone will get 4 pieces of candy. Both are ways students could level off the data to determine the mean. We may also have some students realize they could just take all of the candy pieces back and then fairly share them between the 4 students. In essence, they are adding all the data points and dividing it by the total number of students. It is okay for our students to derive the formula to find mean, but in this instance, though, we're not teaching the formula in a procedural manner, but we're allowing students to build conceptual understanding, derive the formula, and understand how the formula results in the fair share of the data. So by equally taking them all back and then equally sharing them back out to the 4 people, put it here, I can see that each person will get 4 pieces of candy. We've looked at what the leveling off strategy would look like at the concrete level. Let's look at it at the representational level. So we have the same problem about Miss Smith and her students with the candy, but we can see that we have a representation of that data in a bar graph. So, since our students have had hands on exposure to being able to level off to find the mean, our students may be able to then move to applying this at the representational level. So, let me show you what it would look like representationally. So, I can see that Alex has 3, Bailey has 6, Cole has 3, and Damien has 4. Well, I notice when I look at this data that everyone has at least 3 pieces. So I'm going to level it off at the 3-piece mark. So everyone can keep these 3 pieces that are below the red line. But then when I do that, I notice that I have 1, 2, 3, 4 pieces of candy that need to be redistributed. Well, I know that since there are 4 pieces and there are 4 students, each student can get one of those pieces. So I'm going to take this piece and move it over to Alex. So Alex now has 4. I'm going to take this piece and I'm going to move it over to Cole. Cole now has 4 pieces. And this piece right here, I'm going to leave that with Bailey so that Bailey also has 4 pieces of candy. And I don't need to move this or redistribute it because Damien is going to get to keep it so that each student now has 4 pieces of candy. So, through exposure at the concrete level of being able to move the manipulatives to redistribute and level off, we can now do it at that representational level. Leveled the candy off at 3 pieces each, and then redistributed those extra pieces, and each student is going to get 4 pieces of candy.
Hello, teachers. Today we're going to take a look at the balancing point strategy to support the work students will do with IOA 7D in relation to mean distribution. We want to ensure that students understand that mean is an extension of what they already know about fair shares. It allows students to take a set of data and distribute the values equally in order to determine the center of the data. When students are working with IOA 7B, they ask questions, collect data, analyze data, and interpret data. While interpreting data, students should have opportunities to discover and discuss the mean. As mentioned earlier, today we're going to look at how to use the balancing point strategy. In this lesson on the pacing guide, students are given data containing various lengths of names. They will have an opportunity to practice the leveling off strategy as well as the balancing point strategy to determine how many letters each person would have in his or her name if they were to share the letters equally. I will be modeling the balancing point strategy using my own data. So I have collected data about the number of letters in the first names of some of my friends. So here are the different links in my data set. Each number in my data set represents a person's name. I'm going to organize this data by placing it on a line plot. It can be helpful to place the data in sequential order. So I will start with the smallest number, which is 4. So I have 2 4s. Then I notice I have 5. And this just helps students to keep track of the numbers that are in the data set. And then I have 6, and another 6, another 6. Then there's a 7. There's no 8, but then there's a 9. Okay. So now that I have reordered, I can tell that 4 is the shortest name in my data set. Okay. And I can also tell that because I have a 9, that's going to be the longest name that was in my data set. I'm going to use the line plot, and I'm going to number the axis of my line plot with the numbers 4 through 9. So notice that I numbered 4 through 9, including the 8. So when numbering a line plot, it's important to list the data points sequentially on the x-axis and at regular intervals, even if there are no values for the intermediate point. So we're going to be using stacking counters to represent the names in my data set. For every data point, I will use a counter above that value on the line plot. So in other words, for every name that's a part of my data set, I'm going to be using a counter for that person's name. Okay. So I had 2 people who had 4 letters in their name. So I'm using 2 counters to represent those 2 people. I have 3 people who had 5 letters in their name. So I am placing 3 counters to represent those 3 people. I had 3 people who had 6 letters in their names. So therefore I have 3 counters for those 3 people. 3 people, 6 letters. Then I have a 7. Then I have a 9. So one person had 9 letters, one person had 7 letters. 3 people had 6 letters, 3 people had 5 letters, 2 people had 4 letters in their name. So in other words, for every data point, I have a counter on my line plot. So my goal is to determine where the center of this data lies. I want to look at the data and figure out the shape of the data. Where does the mean lie? That's what I'm trying to figure out. So in other words, if I took all 10 names and spread out the letters so that each person has the same number of letters, how many letters would that be? So I will begin by moving 1 counter from each of the outermost points 1 point over towards the center. And I'll continue to do that until I've moved the counters over the center point or the mean. So I'm going from 9 to 8, 1 point over. Then I'll move 1 counter, 1 point over. I'll go 1 point over, 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 and 1 point over. Now that I have done that, I can see that most of the counters are over the number 6, but there are also 3 counters that are over the number 5. This lets me know that the mean lies between 5 and 6. It's always nice when the data turns out where you have like one number, but I wanted to show you an example of where sometimes it doesn't come out as easily as that, but we know it's between 5 and 6. That means if each of my 10 friends distributed the letters in their name so that each person had a fair share, they would each have between 5 and 6 letters in their name. Let's look at this situation using sticky notes marked with X's, more like a traditional looking line plot. Okay, so looking at this example, I'll begin moving towards the center with sticky notes until I've determined the mean. This is the same exact process as before, but you may decide that you want to do sticky notes opposed to the counters, which is perfectly fine as well. So again, I'll move 1 and 1 over, 1 over, 1 over, 1 over, 1 over, 1 over, and 1 over. So again, my mean is going to lie between 5 and 6, and therefore the number of letters in each person's name would be between 5 and 6. Let's look at another example using a different set of data. Okay, so let's try this strategy with a different set of data. In this scenario, I needed to make costumes for students in the school play, so I measured the height of the students who were participating. So here are the heights of the different students that were in the play. Notice that there are now mixed numbers. As we are introducing mean to 5th graders, We need to limit the denominators to halves, fourths, and eighths. Be sure that students are able to order fractions and mixed numbers with unlike denominators prior to determining mean with fractions and mixed numbers. So, as I did before, I want to number my data to help me understand what I have. And that way it just kind of makes it more, makes it simpler to organize the data for me in my brain. So I'm going to start with 3, and I know 3 1/4 is less than 3 1/2, so I'm going to place 3 1/4 first. Then I'm going to place 3 1/2. See if I have any more. Oh, I had another 3 1/4, so I'll just place it right here. 3 1/4. I missed that one the first time. See, this is what students would do when they're counting, right? So that's why it's a good idea to place them in order. 3 3/4. Okay. Then I have fours. I have some fours. 4, 4. Then I have a 4 1/4. And I know that is less than 4 3/4. And then I have another 4 1/4. And then I have another 4 1/4. And lastly, I have a 4 3/4. Okay, so looking at my data, I can see that the least amount or the shortest student would be 3 1/4 feet. And the tallest student is 4 3/4 feet. So on my number line, I am going to start off with a 3, which is going to be uh, the smallest amount on my number line or on my line plot. And then I'm going to place a 5 on this side. The reason being is that I want to be able to place the intermediate point in the right place on my line plot. Between 3 and 5, right in the middle, I'm going to place a 4. Okay. Now, halfway between 3 and 4, I know I'm going to have 3 1/2. Halfway between 3 1/2, 3 and 3 1/2 is going to be 3 1/4. Halfway between 3 1/2 and 4 is going to be 3 3/4. And then halfway between 4 and 5 is going to be 4 1/2. Halfway between 4 and 4 1/2 is 4 1/4. Now, you guys are adults, so I'm going fast. But for students, you will make sure that you are making sure that they understand why you're placing the fractions where you are or the mixed numbers where you are on the number line. Although by this point in the year, they probably would be able to do this pretty independently. But as you're modeling, you want to be just explicit in why you're placing the numbers where you are. So lastly, between 4 1/2 and 5, you would have 4 3/4. Okay, now using my data, I'm going to use the X's to place each one of the numbers from my data set. So I know I have 2 people who were 3 1/4 feet high. So I'm going to put 2 X's to represent the 2 people that were 3 1/4 feet high. Then I had one person who was 3 1/2 feet high. So I'll give them one X there. Then I have one person who was 3 3/4 feet high. So we'll put an X there for that person. 4 and 4. So I have 2 people who are 4 feet tall. And it is important that students understand that each X represents a person or part of the data that you are looking at. 4 1/4, 4 1/4, 4 1/4. There are 3 people who are 4 1/4 feet high. And then lastly, I have someone who is 4 3/4 feet high. No one was 4 1/2 feet, but that's okay. They're going to come between those 2 data points, and that's fine. But we have to make sure we are numbering in regular intervals. So now, just like I did before, I'm going to be moving the x's to find the mean. So I will go over from 4 3/4 to 4 1/2 here. Then I'll take 1 from 3 1/4 and move it to 3 1/2. One on this side, one on this side, one on this side, one place over in this side, one place over here, one place over here, one place over here, one place over right here, one place over here, and one place over here. So looking at my data, I can see that most of my X's, which means most of the students, are going to be about 4 feet. Will be 4 feet. And then there are a few students who are at 3 3/4 feet. So most of my data is going to lie between 3 3/4 and 4 feet. As we continue to work with mean, especially with whole numbers, students may discover the mean formula by adding all the values together and dividing by the total number of data points. That is a valid strategy. However, it is not an expectation for mastery within fifth grade, which is okay, but it's just not an expectation for mastery within fifth grade. Make sure students have manipulative that they're able to manipulate as you are working with mean distribution in fifth grade.